Okay, now we're on to molarity. So fun stuff. Again, you can reference if you want to look this up, Kim Libre, free textbook. Here's the site where I'm pulling the information from. And this is their main unit of concentration that we use in the second semester. We use colligative properties. We'll learn others. In the textbook that you're using, they have addendum with the other units, but molarity by far is the most common. And I think you'll see why that is quickly. So molarity is moles a liter. So that's it, number of moles of a solute over the liters of the solution. And so in the basic problems, where you're given moles of solute and volume of a solution, easiest one, liters. And so you simply substitute similar to density. Now you just substitute and you're able to solve for the molarity of it. And of course, we're going to make it more and more complicated and difficult. And so here's an example. Then what is the molar concentration if you have 2.4 grams of HCl dissolved in 1.56 liters? All right, so very common problem, except for you wouldn't be given liters, you'd be given milliliters and then have to convert to liters. Why? Because milliliters is the most common unit in the lab, as you've probably seen so far. All right, so how do we do it? Well, again, we have to get it to moles of the solute. And so you're given grams. So grams to moles, that's what you looked at earlier in this chapter. So the molar mass of the compound, adding it up, and that'll give you moles of the HCl. And then we simply substitute into the molarity relationship to get moles over liters, and we can get the concentration of it. Okay. So now we can see this in the exact same problem and a little more difficult. So solutions prepared dissolving 42.23 grams of ammonium chloride. All right, so you're given the formula. You could easily make it a harder problem by then using the name ammonium, the polyatomic ion, chloride, and then having to figure out the formula. All right, and enough water to make 500 milliliters of solution. Calculate the molarity. So now you have a bunch of kind of pieces, but the most often is we go through moles. All right, moles is the linchpin for a lot of the calculations that we'll do. So we're given grams of volume in milliliters, and we're asked to find molarity. And now that the first step would be, what is molarity? It's moles a liter. So we need to get moles. We'll get moles from the grams, and we'll get liters from the volume in milliliters to liters. All right. So here's a little graphical representation. I don't think it's the best, but grams to moles using the molar mass. And remember, you're going to use that equality. So you have grams. Grams is going to go on the bottom. Moles is on top. When you add up that mass from the periodic table, that is always relating to 1 mole. All right. So you just simply add it up and you'll have 1 there. And now we can see it in the normal dimension analysis form. You would have grams to moles, and then you take that moles and simply divide it by the volume in liters to get the molarity. So now you can scroll through, you can see common things, working backwards, finding volume is probably one of the most common just because it's on the bottom and solving. And probably you saw that experience when you solve for volume in the density problems. The same thing happens here if you made mistakes with that volume, with rearranging with the kind of algebraic relationships.